About some basics about ecosystems, how ecosystems are organized, community, habitat, biotic, abiotic, population, and so forth. And then we introduce food chains. Today we'll be talking about food webs as well as food chains. Now if you look here, what is this? Is this a food chain or a food web? Matthew?
Food web.
Food web? Samantha, you disagree? Why do you think a chain?
Because a web has a whole bunch of zeros within the outside.
Yeah. This is a food chain because there are no interconnections. This just shows one organism, say the algae, which are eaten by the mosquito larva, which is eaten by the other larva, eaten by the perch, eaten by the pike. So we have one thing to another to another. That's a food chain. Each organism only has one food source in this food chain. Food webs would be several of these food chains connected together, indicating that different species have alternate food sources as well. All right, as we talk about food webs, we're going to use these terms. And I think probably we just saw them in the brain pop, and also I think most of these should be familiar with you from elementary school. Raise your hand if you can tell me, what is an herbivore? Rachel? An animal that eats only plants. A plant eater. Like, for example, a deer is an herbivore. Eats only plants. But a carnivore, Sean? Something that only eats meat. A wolf, for example, is a carnivore. When we talk about carnivores, we talk about their predator-prey relationship. Whereas the predator is the hunter. What is the prey?
The victim.
The victim, the hunted.
The hunted.
Yeah? What is an omnivore? Yeah, an organism that eats both plants as well as animals. All right, so what's a heterotroph? This is a review we talked about it yesterday. Heterotroph, Sydney? Has to go out and find other organisms to consume. Has to go out and hunt for food, find food somewhere, and eat some other organism. Yeah. Cannot make its own food. And what is the other word we use for a heterotroph?
Consumer.
Consumer. They have to consume other organisms to get energy.
Those are final foods.
Look at yesterday, it's on the board. How about autotrophs? So what is an autotroph? Yeah?
They make their own food.
They can make their own food using sunlight and photosynthesis. What is their food? What do they actually make? Glucose. I don't know, that just, Spencer. That may just mean sort of where you're fishing, the bait you're using is more likely to catch those fish.
Yeah.
But they are more common in that lake, and we'll talk about why in this slide, than things like a lake trout or a bigger pike or something. And there's a reason why there's more of those smaller fish than there are larger. Alexis?
Is autotroph a producer?
Yes, the other word for an autotroph is producer. They can produce their own food using sunlight. Good question. People always ask about those carnivorous plants, like a Venus flytrap or a pitcher plant, something like that. They actually are still autotrophs. They still make glucose using sunlight. Why do they capture insects then? Does anybody know? They're not doing it for energy. most of those plants live in soil that's very low in nutrients. Bogs, for example, and stuff where there's very low nitrogen in the soil. So what they actually do is they still make their own glucose using sunlight, but they don't get enough of those other nutrients from the soil. So when they capture those insects and their bodies break down, they actually absorb things like nitrogen and phosphorus from those insects. Those aren't things they actually use for energy, but they use those nutrients to function normally. So that's usually why they capture those insects. So they're still considered autotrophs. All right, so a food web. We're talking about food chains, and we just said a food web is more complex. It shows more feeding relationships within an ecosystem. Arrows point in the same direction, though. From what was eaten to what ate it. And a food web is made of several food chains sort of connected together. If you look at, is this a food web or a chain in the top right? Web. I can look at a food web like this and I can identify several food chains. So one food chain might be the plant, to the shrimp, to the fish, to the bird. That's one food chain. Another food chain that's present here might be the plant, to the crayfish, to the bird. Those are food chains that I can identify from this food web. And a food web is a more accurate representation of a real ecosystem. In real ecosystems, usually each species doesn't only eat one other thing. Most of the time, most species have several different food sources they might eat. So a food web gives us a more accurate picture of what's happening in the ecosystem. All right, if we think about this ecosystem where you have this food web, obviously it'd be in the water. It's got aquatic plants and crayfish and shrimp and stuff, fish. Which of those organisms would you expect to find the most of in a body of water? Rachel?
Shrimp.
Shrimp, you think there'd be the most of?
Plant.
The plant? How many people think the plant? Yeah. The most common organism would be the plant. What would you probably find the most next on the list after that? Probably the shrimp. What would be after that? Cindy? Probably the crayfish. What up after that?
There goes lobster.
Or, no, that's a crayfish. Could be a lobster, you don't know. They look the same, depends on the scale. Then what?
The sand
The
shrimp.
fish? What would you expect to find the least of? The big, I don't know if it's a heron or a egret. But yeah. Now, why is that just based on what you know? Like your idea about it? Guessing? All right, you're right. In just about every ecosystem, the most abundant, the most common, the largest organism is always the producer. The base of your food web is always those producers. And then as you move up the food chain, there are fewer and fewer of those organisms. Think about what's one of the top carnivores that you can name?
Dinosaur. Lion.
A lion. So if you think about when you've seen, videos and stuff of lions, do you see a big herd of 300 lions running around the savannah? No. They may live in a small pride, but there's only a few of them over a very, very large area. What's another big carnivore?
Hyenas.
Okay, hyena.
Tyrannosaurus.
Sharks. Are there schools of 40 or 50 sharks that swim around the ocean?
Yeah.
No. They live individually, and each one has a very wide range. Think about a bear or eagles. You don't see a flock of eagles flying through the sky. You see them sort of individually. That's because those top carnivores are very limited in the number that there are, because there's just not enough energy in the ecosystem to support a large number of those top carnivores. And the reason is because we have this thing called the energy pyramid that explains why that's the case. Hold on. So in an ecosystem, every time one species, one organism eats another, most of the energy, let's say when a deer eats some grass, chews it up, digests it, about 90% of the energy in the grass that the deer ate gets burned up by the deer, just staying alive. Only about 10% can actually go into the deer growing larger. And so then when a wolf eats the deer, the same thing is true. Most of the energy that the wolf consumed from the deer gets used up. Only about 10% can make it into the wolf's body tissue. And every step up the food chain you go, you're losing energy. Okay? About 90% of the energy is lost. Only 10% can make it to the next level. And so eventually you run out of energy. So this pyramid that we draw based on the ecosystem shows us that the base of the pyramid, the most abundant organism are the producers. The next most abundant are the first level consumers. And then the second level consumers and so on. We get fewer and fewer organisms as we move up our food chain. So 90% of energy gets lost each step. Spencer?
You know that dinosaur with like, the big tail and has like a mace in the back of it? You know what that's called?
Stegosaurus?
Isn't that one a carnivore too?
Probably. So this is what we call the energy pyramid. You know, if you think about, if we use as an example, the courtyard ecosystem, we talked about it yesterday. Let's say in that courtyard you have the grass, you have some mice. Let's say you have the grass, you have some crickets, you have the ducks. And let's say you had a hawk in there, that tree.
No.
Which would you expect there to be the most of out there?
The grass. No, the grass. Starve. The grass.
The grass. What would be the next biggest population? The crickets. You would find lots of them out there. After that, the ducks would probably eat the crickets.
The dogs.
And then the hawk, which might eat one or two of the ducklings.
You guys tell me you're so
That's why I want a hundred.
All right. Here's another example of this.
Quack, quack, bam!
This is obviously an ocean. Yeah, it's okay. It's why it's and so as the sun shines onto the surface of the ocean, the producers can absorb some of that energy. Not all of it, but some of it. Then these small little microscopic animals that eat the algae, they can get about 10% to make it into them. Then these small fish that eat those, there's fewer of those. Then the larger fish that eat those, again, fewer and fewer. And again, that's why when you go fishing, you don't catch lots of really big fish. In a small-sized lake, you would have lots of plants in there. You'd have a lot of small fish, fewer of those medium-sized fish, and then the big fish that eat those, there's only going to be a few of them in there. Okay? Because as you move up that food chain, energy is lost along the way.
Have you ever seen that show, River Monsters?
I have not.
It's about River Monsters.
Great.
They're just crocodiles.
All right, so that's just showing us how energy is lost. This looks like a Fire Nation show. If you ever watch it.
Oh, Avatar: The Last Airbender. That's a great show.
Alright.
That's a great show. Oh, that yeah.
Energy pyramid. Again, this is just another example and shows us sort of the same thing. In this case, we have sunlight shown. We have plants, crickets, mouse, and a snake.
It looks like the Empire.
And so as we move up in that food chain, less and less organisms are present. We have less and less energy to support each level. So the energy, what happens to that energy?
It gets smaller.
It gets used. It gets lost. Okay?
Or here, wait.
What's that?
Why is that?
You don't have, do you have this slide?
Yeah.
Yeah, we do.
Oh, sorry, flip ahead.
And then we got to flip back.
All right, what happens to energy in this energy pyramid?
It's used.
It's used. Okay?
You write that?
Yeah.
Oh,
It's you.
It's well, you could say the energy is decreasing each step up the food chain you go. Where is it going?
into the
Being used by each
being used by
species.
species.
What is number 2? You waste one.
You still use energy just to stay alive, even if you're a sloth.
But they don't do anything.
They do, they eat, and they exist. The mere existence uses energy. Number 2, where is the energy? It's being used by the organisms. So the energy decreases is number 1, and where is it going? It's being used to keep the organisms alive.
Wait, where's energy going?
Being used by organisms.
Being used by organisms.
So again, we have on the bottom producer, first level consumer, second level consumer, third level. That's joules, it's a unit of energy.
Those are the 100J, the 10J look like
All right.
first take over.
Now, is this a food chain?
No,
that's a food web.
That's a food web.
Yes.
So again, if you look at a food web like this, what's a food chain that you can identify in this food web? Samantha? Okay, that's a sumac, I think. Go ahead. To the bunny? To the fox. That's them. That's
Nice.
the food. That's one food chain. What's another one, Fallon?
The other plant, to the cricket, to the frog, to the owl.
Good.
Oh, Gamara.
Now, which species in this food web would you expect to find the most of? Alexis? Yeah, with these plants. What would you expect to find the least of in this food web?
The fox.
Fox and owl and snake.
Probably the fox and the owl. Snake.
No, I'd say the fox. We
All
got
right.
3 arrows.
What's that? Yeah, there might be more snakes than the owls because that is one level below them. But again, you don't see huge numbers of those top carnivores in an ecosystem.
Does anything eat the fox?
Nope.
No, the fox.
All right, so here we have just one more example. We have plants, the largest, then we have crickets, some birds that eat the crickets, and then the owl that eats the birds.
Hey, it's gonna.
All right, producer, consumer, decomposer. I know it's already filled in. Producers, consumers, and decomposer. The rabbit's the consumer. Consume other organisms for energy. The tree is the producer. It grows using the sun's energy, making its own glucose. And then the fungi is the decomposer.
Why is this packet so long?
All right, so you have here a food web. I want you right now to go ahead and answer those 4 questions based on this food web.